Hello everyone, myself Dr. Amit Kumar Yadav, Associate Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today we are going to explore something fascinating, how AI thinks, not just what it says, but why it says it. Welcome to Understanding AI, the magic behind the curtain. What is explainability? Why should we care? Asks why. Explainability means asking your AI assistant why it made a certain decision, not just accepting the answers. Build trust. When we understand AI's reasoning, we can trust it more, catch mistakes earlier, and build fairer systems. Fix and improve. In another word, we can say that by asking a simple question, have you asked your AI assistant why it gave a certain answers? That's what explainability is all about. It helps us build trust, catch mistakes, improve system because if we don't understand AI, we can't fully trust it. What is multimodal? Multi means many. Modal refers to a type or channel of information. Think of it like a human sense. So, multimodal means an AI that receives, processes, and reason with many types of information at once, just like humans do every day. So, we can say here the terms multimodals, it contains multi, which means many. Modal means types of informations. So, so multimodal AI works like human. It uses multiple senses at once. Example of multimodal information. So here text contains word, sentence, paragraph, the most familiar form of data. Image, it contains photo, drawing, chart, visuals, snapshot of the world. Audio, speech, music, environmental sounds, information through hearing. Video, moving image combined with sound, rich time-based data. Structured data, numbers, tables, and charts. Precise quantitative signals. So we can say here AI doesn't just read data, it can process text, image, audio, video, structured data. Each of these is a different way of understanding the world. Putting it all together, multimodal AI. So, multimodal AI can hear, read, and see all at once. It combines signal from multiple sources to form a richer, more complete understanding of the world. Take an example here, an AI that watch a video clip, read its transcript and listen to the audio tone, then tell you whether the speaker seemed happy or upset. So here imagine an AI watching an video. It sees the visuals, reads subtitles, listen to tone, and then decide is the speaker happy or upset. That's the powerful but also complex. Why is multimodal AI hard to understand? The core challenge. When AI blend many types of information, it, it is just like a complex recipe. It is difficult to know which ingredient matter most for the final result. Was it the image that drove the decisions? Was it a keyword in the text or the combination of both? This is exactly the problem multimodal explainability sets. In another word, we can say here the core challenges there is problem when AI combines all this information, it becomes hard to answer. What influenced the decision most? Was it image, text, or both together? That is where multimodal explainability comes in. Multimodal explainability via attention, how AI learn to focus, and how we can see what it is. What is attention in AI? Key mechanism. Just like you focus on keyword while reading or key object in photos. AI attention mechanism help models focus on the most relevant part of its input. In multimodal AI, attention helps the model link part of one modality to another. For example, connecting the word tail in a description to the actual tail in an image. So attention concept means just like you focus on important word while reading, it also learns where to focus. It decides what matter most. How attention explain multimodal AI. Imagine an AI describing a photo of a cat. Attention mechanism can reveal text to image link, which word in the descriptions like fluffy or tail are directly linked to regions in the image. Image to text link, which part of the image like the fur texture or ear shape the AI focus on to generate a specific word. Decision reasoning. Together, these links shows us what the AI looked at and why it said what it said, making the reasoning transparent. Suppose AI describing a cat. Attention help it link the word tail to the actual tail. Focus on fur when saying fluffy. So now we can see what it is thinking about. Visualizing attention with heat map. Attention it can be displayed using heat map, layered on the top of image or highlighting with bright text. Brighter, warmer, cooler colors shows where AI paid the most attention. So this transforms invisible AI reasoning into something we can actually see and interpret it. A powerful tools for student, researcher, and developer alike. So, in another word, we can say that we can even visualize the attention mechanism using heat map. Brighter area means more attention. Uh, Suddenly, AI is no longer a black box. It becomes something we can observe and interpret. Joint feature attribution for multimodal models. Understanding which features matters and how they work together across modalities. What are features? Features are individual characteristics or signals in AI extract and learn from raw data. They are the building blocks of understandings. Image features fur color, ear shape, taste length, facial expression, visual patterns the model detects. Text features, sentiments, keyword, topic, tone, linguistic signals, the model extract from language. Audio features, pitch, tone, rhythm, volume, acoustic properties that carry meaning in speech or sound. So feature attentions answers a key questions. Which features matter most? Think of it like a courtroom. Each feature is evidence. The model decides which evidence influence the verdict. What is features attribution? Features attribution answers the question how much did each features contribute to the AI decisions. It is like a courtroom. Each piece of evidence features gets a weight of responsibility for the final verdict output. Example: did the dog fluffy ears or waggling tails lead the AI to predict it was happy? Feature attribution tells us. Joint attribution, the multimodal twist. But in multimodal AI, feature doesn't work alone. They work together. Example: text say I failed. Image shows a sad face. Together AI predicts sadness. This interaction is called joint attribution. So in another word we can say that joint feature attribution means in multimodal AI, features from different sources must be evaluated together, not in isolation. So joint features attribution reveals how cross-source features interact, understanding neither alone but together as a combination driving the AI predictions. The real world importance. What do you mean by the real world importance? Where we are using this real world importance. So joint attribution help us unpack complex interactions between data types, which reveals insights that single modality analysis would miss entirely. Take an example of, say, word education. Show a diagram and tests work together to build student understanding. Healthcare reveal how symptom text and scan image jointly influence a diagnosis. Fairness expose whether the AI is over relying on one source or not. So, in another word, we can say that why it matters. This is important in real life. In education, we will include text plus diagram. In healthcare, reports and scan. In fairness, detecting bias. Understanding combinations helps in building better AI. Class model explanation analysis. Checking that AI explanations are consistent and coherent across each type of data it used. Class model looking across information type generate explanation modality A. An AI solves a math problem and produces a text-based explanation of its reasoning steps. Cross-reference modality B, we check does the text explanation align with the visual diagram of the same math problem. Consistency check if the text says the angle is 90 degree but the diagram shows 45 degree. Cross modality analysis catches the mismatch. So cross modality concept, now we go one step further. Cross modality means checking across different data types. Does everything agree? Analyzing explanation across modalities. So here cross modals analysis compare explanation generated from text. So one here you will get here say text explanation, second one say visual explanations. So cross modality analysis compare explanation generated from text alone versus those also incorporate visuals and audio context. The key questions are: does the explanation hold up when we switch modalities? Is the AI reasoning consistent across all information type? Are there contradictions we need to resolve? Now, cross modal concept. Now we go one step further. Cross modals means checking across different data types. Does everything agree? Then real world examples, education AI tutors. System like interactive sketchpad combines text, hint and visuals diagram to guide student through math problem. Text hint. Step by step written clues that guide the student's thinking process. Visual diagram, dynamic drawings that visually represent the problem structures. Cross check, cross model check. Ensure hints and diagram tells the same stories, preventing student concept. So, by taking educational examples in AI tutors, text give hints, diagrams shows visuals, both must watch. Otherwise, student get confused. The future's smarter, fairer, and more understandable AI. Multimodal explainability is the foundation of AI we can truly trust. It allows us to open the black box and see clearly how decisions are made across text, image, audio, and beyond. Better explainability, better AI for education, healthcare, science, and every field that depends on trustworthy decisions. So, what is big idea here? Multimodal explainability help us see what AI focus on, understand how features combine, ensures consistency, and ultimately build AI we can trust, because the future of AI is not just smart, it must be understandable. Making AI fair and trustworthy, understanding explanations. What is AI explanation? Think of AI as a smart assistant. When it makes decisions, an explanation tell you why, like showing its work on a math test. AI makes decisions, predicts an output or classifies input. Explanation is generated. The reasoning behind decision is revealed. Human understanding. So, in another word, we can say that think of AI is like a student solving a math problem. It gives answer, but that's not enough. We also want to see the step right. That's what an AI explanation does. It shows us what decision made, why it was made, and whether we should trust it. Why do we need explanation? Explanations are not optional, they are essential. They help us trust the system. It means believe what AI tells us and feel confident in its output. Debugging errors, find and fix mistakes before they cause real harm. Learning, understanding how the AI works so we can improve it. Fairness, ensure that AI doesn't treat some group better than others. Fairness in AI. Explanation. How do we make sure AI treats everyone equally and that its explanation reflect the commitment? What is fairness in AI? Imagine a teacher's grading EGs. A fair teacher grades all students equally, regardless of their background, name, or appearance. AI must follow the same principles, making decisions and generating explanations that are equally valid and unbiased across all groups of people. Fairness doesn't mean identical outcomes. It means equally justify reasoning for all groups. In another word, we can say that imaging a teacher's grading exam. A fair teacher doesn't judge based on names, background, appearance. AI must follow the same principles. Fairness means equal reasoning for everyone. Bias in AI, the hidden problem. AI learns pattern from data. If the data reflect past inequalities, the AI will do, often without anyone logic. Where bias comes from: training data collected from a world that was not always fair. Historical hiring records, graded assignment, loan approval all carries embedded biases. A real example: an AI trained on past students' performance data may unfairly predict lower success rates for certain demographic groups simply because those patterns existed historically. The impact: biased AI affect education, hiring, healthcare, and criminal justice, making fair explanation not just a technical goals but an ethical goals. Bias in AI: here's the hidden problems. Bias: AI learns from data, and data reflect the past. If the past was fair, AI can inherit the unfairness. For example, an AI predicting student success might unfairly rate some group lower, not because of ability but because of biases historical data. Fairness aware methods. Fairness aware explanation methods. To fix this, we use fairness awareness explanation method. This method are analyze decisions, compares across group, detect bias in reasoning, not just outcome but explanation themselves. How do fairness aware method work? These systems analyze AI decisions, compares reasoning across group, flag unfair patterns, correct them. The goal is simple: equal quality of explanation for everyone. Fairness means equal reasoning for all. A fair AI doesn't just produce fair outcome, it produces equally well justified, equally transparent explanation for everyone. Let's remember this: fairness is not just about equal results, it is about equally justified reasoning. Robustness of AI explanation. Can an AI reasoning hold up under pressures? Robustness is what separates explanation you can rely on from ones that crumbles with the slightest change. So, robustness means think of a strong bridge. Even in storm, it stand firm. Similarly, AI explanations should remain stable even if inputs change slightly. Why does robustness matters for explanations? If small changes causes a big explanation shift, that is dangerous. Example: a student misses one class, and student AI label them high risk. That's not reliable. That's fragile reasonings. Robustness testing for explanations. Now, so how do we test robustness? We generate an explanation, slightly change input, observe differences, If explanation changes widely, not trustworthy. If they stay stable, then it is called as reliable. Robust versus not robust. A robust explanation is smooth, predictable, stable. A non-robust one is erratic, unstable, unreliable. Only robust explanation should be used in real-world decisions. Consistency and stability. Two important ideas here. Consist- Consistencies, similar cases, similar explanations. Stability, small changes, small effect. Together they build trust. Putting it all together, fairness, robustness, consistency, and stability are not a separate goal. They work together to make AI explanation genuinely trustworthy. Real world examples considers student performance system. AI can flag AI risks student, but without explanation. It just labels. With good explanation, it becomes actionable insights. The real challenge is even perfect AI is useless if people can't understand it. So we must use simple language, avoid technical jargon, provide actionable advice because AI is for human, not machine. Empowerment. When explanations are fair, robust, clear, they empower teachers, students, decision makers. AI become a partner, not a mystery. Key takeaway, let's summarize. Fairness, equal reasoning for all. Robustness, stable explanation. Consistencies, similar logic for similar cases. Human centered, easy to understand. If we achieve all four, we don't just build powerful AI, we build AI that is ethical, reliable, and trustworthy.